Hello and welcome to Algebra 1 Lesson 29. In this video, we're going to learn about adding and subtracting polynomials. All right, so we're going to start out today by just talking about some basic vocabulary. So we previously learned the definition for a term. So recall that a term is a number, a variable, or the product of a number and one or more variables. So as you may recall, in an algebraic expression, terms are separated by plus and minus signs. So for example, we have 2x squared minus 7x plus 4. So this is a term, this 2x squared. And then we have a minus sign. This is a term, this 7x. And we have a plus sign. And then this 4 is a term. So notice how this is a barrier, right, between your terms. So you have the term 2x squared, the term 7x, and then the term 4. All right, so I also want you to recall that the number that is multiplying the variable is called a coefficient. So for example, if I have something like 3x to the 5th power, the 3 that's multiplying this x to the 5th power is known as the coefficient. Or as another example, you could have, let's say, 7x squared. 7 is the coefficient. And again, I just give you these definitions because I'm going to be referring to things later on. I might say, hey, just add the coefficients together, so you need to know what I'm talking about. All right, so now let's talk again about like terms. So when we say like terms, we mean terms with the same variable or variables raised to the same power or powers. So the coefficients can be different, but that's the only thing that can differ. So let me give you some examples. Here we have 5x squared and we have negative 7x squared. So these are like terms. These are like terms. Again, look at the variable. This is an x and this is an x. And then look at the power that it's raised to. This is raised to the second power and so is this. The coefficients are different, right? If I highlight that in a different color, this one is 5 and this one is negative 7, but that's okay. Again, same variable or variables, if you have more than one, raised to the same power, or could be powers, again, if you're dealing with one of those situations. All right, let's look at this one right here. We have 3x to the 4th power, y squared. Then we have 9x to the 4th power, y squared. So again, these are like terms. If you look at the variables, again, we have two here now. We have x and we have x. We have y and we have y. Now you're looking at the powers. We have x to the 4th power, x to the 4th power. We have y squared and y squared. So these are like terms. And let's say you got a situation where you had something like 3x to the 4th power y squared. And then this differed by just a little bit. Let's say it was 9x cubed y squared. These are not like terms. Not like terms. Because this right here, this is x cubed and this is x to the 4th power. So everything in terms of your variable and the power that it's raised to has to be exactly the same. It can't differ even by a little bit. So in this example here where we have negative 2z and 4x, obviously those aren't like terms, right? They don't even have the same variable. This one has a variable of z. This one has a variable of x. So these are not like terms. All right, so let me give you the textbook definition for a polynomial now. And you're going to read this, and it's going to be a little bit confusing at first. And hopefully I can give you a little insight into kind of how you can look at the examples and say this is a polynomial and this is not a polynomial. So a polynomial in x, or it could be another variable like y or z, whatever you want, is a single term or the sum of a finite, right? Finite means it has an end, amount of terms, ax to the power of n, where a is any real number and n is any whole number. So what they're saying is that we have ax to the power of n. A is any real number. So anything you can think of can be plugged in for a. Could be a negative, could be a positive, could be a fraction, could be anything you can think of can be plugged in there. So any real number. Any real number. X is the variable. So that doesn't have to be x. As I just said up here, it could be y or z or w, whatever you want to use for that. And then n is the exponent on x, and it says that it has to be a whole number. So it can be 0, it can be 1, it can be 2, something like that. So what you want to pay attention for, you want to look for negatives, and you want to look for fractions and things that are not whole numbers. If you see that in place here, you don't have a polynomial. Okay, you don't have a polynomial. So this, any whole number. So let me give you an example. We have something here, 3x squared. Okay, and remember, we're looking for ax to the power of n. So a can be any real number, and so 3 here is representing a. So that's fine. Then we have our variable x, and it's squared. Remember, n has to be a whole number. 2 is a whole number. So this is fine. This is a polynomial. This is a polynomial. So if somebody asked you on a test, is 3x squared a polynomial, you would say yes. But there's a further definition for this type of polynomial. If you have a polynomial with a single term, meaning it's just one term here, 3x squared, it's called a monomial. Okay, so this has a special name, monomial. So let's say we saw something similar to this on a test. Let's say we saw something like 3x to the power of negative 2. Would this be a polynomial? Well, the answer would be no. The exponent on x cannot be negative. It has to be a whole number. So 0, 1, 2, 3, etc., etc. If you saw something like x raised to the power of 1/2, that's not a polynomial. Okay, that doesn't work. So we'd have 3x to the power of 1/2, not a polynomial. So this one, yes. This one, no. All right, what about this? 5x to the 4th power minus 7x squared. Just look at the variables and look at your exponents. So 5 is okay. Anything can be the coefficient for the variable. Remember, that's any real number. When we think about this as ax to the power of n, so this can be anything. The exponent on the variable has to be a whole number, and in this case it is. So this is okay. So this one checks out, and then this checks out as well. This is a 2. So you have a 4 and then a 2. So everything checks out. So this is a polynomial. Now, we have a special name for a polynomial with 2 terms only. Okay? It's called a binomial. Okay, so this is a polynomial with 2 terms only. Again, a monomial, which we saw in the previous example, is a polynomial with 1 single term. A binomial, polynomial with 2 terms. All right, what about a variation of that? So we have 5x to the power of negative 4 minus 7x squared. Well, no, this is not going to work. If I look at my exponent on x, it's a negative 4. You are not allowed to have a negative as an exponent when you're thinking about a polynomial, right? It's got to be a times x to the nth power, where n is a whole number. Whole number. This is an integer, negative 4, so that's not going to work. And later on, we're going to see that if you have something like this, really I could write this as what? I could write it as 5 over x to the 4th power, right? Using our rules for exponents that we've previously learned, then minus 7x squared. And we're going to talk about these types of expressions. They're known as rational expressions. We'll see those here shortly. But for right now, you just need to know that when you see something like this, it's not a polynomial. All right, so you might also have polynomials that have more than one variable involved. Same rule is going to apply. You're basically looking at the variable parts and making sure that you don't have any negative exponents and any fractional exponents. Basically, you want the exponents to be whole numbers only. So if I look at negative x to the 5th power y cubed plus 3x squared y minus 4, just look at the exponents. So I have 5, a 3, a 2. This is really a phantom 1 here. So I can put that as a 1. And then if we wanted to, we could write this as 4 times x to the power of 0, y to the power of 0. We could do that. Remember, something to the power of 0 is 1. So really, this would simplify to 4 times 1. But this doesn't violate our definition of a polynomial because the exponents for the variables have to be whole numbers. 0 is a whole number, so this would still be a polynomial. So we have negative x to the 5th power y cubed plus 3x squared y minus 4. This is a polynomial. Now, if I see something like negative x to the fifth power y to the power of negative 3 plus 3x squared y minus 4, the difference here is that I have a negative 3. And so now, because I don't have a whole number as my exponent, this is not a polynomial. And again, you might see a variation of this. You might see something like negative x to the fifth power, let's say y to the power of 1/3, plus 3x to the 1/2 power, y minus 4. You can't have fractional exponents either. Again, everything has to be a whole number in terms of the exponent for you to have a polynomial. All right, so kind of the next thing we want to talk about is the degree of a term. Okay, so you're going to have a degree for your term, and then you're going to have a degree of the polynomial. Okay, they could be the same or they could be different. Just depends on the situation. So the degree of a term, okay, the degree of a term is the sum of the exponents on all variables of the term. So for example, if I want to look at 7x to the fourth power, what's the degree of this term? Well, if I look at the definition, again, the degree of the term is the sum of all exponents on all variables of the term. So I just have an exponent of 4 here, and that's it. So the degree is 4, and that's for the term. It's also the degree of the polynomial, but again, those could be different. It just depends on the situation. So the degree, let me be more specific and say the degree of the term is 4. Now, for this one, we have 3x squared y to the sixth power. So the degree here is going to be 8. The degree of the term is 8. And that's because I looked at the exponent here, that's 2, and I looked at the exponent here, that's 6. I just summed them. 2 plus 6 is 8, so that's how I got that. So if I look at the next one, I have negative 2xy cubed z to the ninth. Again, I'm just going to sum my exponents. Now, a common mistake here, you don't see anything written as an exponent for x. But remember, it's a 1. X to the first power is x. So don't forget that, because a lot of students will just go, okay, 3 plus 9 is 12, and they're done. They forget about that x raised to the first power. So you really have a 1 here, a 3 here, and a 9 here. So 1 plus 3 is 4. 4 plus 9 is 13. So the degree of the term is 13. And what if I see a single number like 5, and someone asks you, what's the degree of this term? Well, remember, as I just showed you, you could write this as 5 times some variable raised to the power of 0. So if I sum the exponents here, I just have an exponent of 0, and that's my degree. So the degree of the term is 0. All right, so now let's talk about the degree of a polynomial. So the degree of a polynomial is the largest degree of any non-zero term of the polynomial. So essentially what you're going to do is look at each term of the polynomial, find out which one has the largest degree, and then that's the degree of the polynomial. So for example, if we have 8x to the fourth power minus 7x cubed plus 5, I look here, I have a degree of 4, a degree of 3, and then a degree of basically 0, right? I could put this as x to the power of 0. So I know that the largest degree of any term is 4, so the degree of the polynomial is 4. So this polynomial has a degree of 4. Well, again, when you start getting stuff with more than one variable in it, and you're going to get a lot of that in Algebra 2, not so much in Algebra 1, you really have to take your time and add all of them up and try to see what the largest degree is for any term. Sometimes you'll get like 7 or 8 of these in a row. They're trying to trip you up, and you'll have multiple ones in each one, so you really have to go through and take your time. So for this one, I just count the exponents. So I have a 7 and a 7. So 7 plus 7 is 14. So my degree for this term is 14. For this one, I have a 5, and remember, I have a 1. So you have to remember that. So important that you don't forget. So this is a 1 there. So 5 plus 1 is 6. And then here, if I see a constant, the degree is always going to be 0, right? Because I could write this as x to the power of 0. So I don't really need to put that the degree is 0. Obviously, that's not going to be the winner unless I just had a single term polynomial that was just a constant. So in this case, 14 is the largest degree of any term. So the degree for the polynomial here is 14. So this polynomial has a degree of 14. So what about something like a constant like -10? Well, the first thing is, how do we make this match the definition of a polynomial? Remember, a polynomial, you get something like ax to the power of n, where a is a real number and n is a whole number. We could write -10 times, again, x to the power of 0, and this fits your definition. A is a real number, that's -10, x is there, and then n has to be a whole number, 0 is a whole number. And then if we were to simplify this, it's just -10 times 1, which is what? It's just -10, right? So that matches up with our definition. Now, for the degree for this thing, again, you're just looking at the exponent, which in this case is 0. So the polynomial here just has a degree of 0. So this polynomial has a degree of 0. So just look out for that on a test, because you might see a single number like that and say, well, this doesn't have a degree. There's no variable to look at. Yes, it does. The variable is whatever you want it to be. It could be x or y or z or whatever you choose, raised to the power of 0. All right, so kind of the last thing we're going to talk about before we get into actually adding and subtracting polynomials. When we write polynomials, it is custom to write them in what's known as standard form. So this means the term with the highest degree is first, then followed by the next highest, and so on and so forth. So something like this, 3x plus 7x squared minus 5x to the fifth. So the term with the highest degree would be this one, -5x to the fifth power, right? Your exponent there is 5, this is 2, and this is basically 1. So this would be first. So you'd have -5x to the fifth power. The next highest, you have a 2 here and you have a 1 here. So this is the next highest, so 7x squared. And then this is the last term, so plus 3x. So this is that polynomial written in standard form. Again, it's just placing it where the term with the highest degree, or the largest degree, is first, then followed by the next largest, and so on and so forth. So we have this term has a degree of 5, then this term has a degree of 2, then this term has a degree of 1, right? So on and so forth. All right, let's take a look at one more of these. So we have 9x plus 12x to the 9th power minus 4x squared plus 3x to the 7th power plus 5x to the 5th power. So the highest degree is going to go first. So if I look here, I have a degree of 1, I have a degree of 9, I have a degree of 2, a degree of 7, and a degree of 5. So 9 is the largest, so I'd start by writing 12x to the 9th power. And I'm just going to line this out just so I know I've used it already. Then if I look at the numbers that are remaining, 7 is the next largest. So then plus 3x to the 7th power, line that out. Then 5 is the next largest, so plus 5x to the 5th power, line that out. Then I have this -4x squared, right? That 2 is the next largest, so minus 4x squared, line that out. And then this is what's left, so plus 9x. So I can just erase all this now. And so 9x plus 12x to the 9th power minus 4x squared plus 3x to the 7th power plus 5x to the 5th power, written in standard form, is going to be equal to 12x to the 9th power, that's first, plus 3x to the 7th power, that's second, plus 5x to the 5th power, that's third, minus 4x squared, that's fourth, and then finally, in 5th place, plus 9x. So you can see how it goes in descending order. You have an x to the 9th, an x to the 7th, an x to the 5th, an x squared, and then an x, or an x to the 1st power. All right, so now let's get to the meat of the lesson. And this is actually the easiest part of this lesson. Once you get past all the kind of vocabulary stuff that you have to learn, it's really, really easy to add and subtract polynomials. So to add polynomials, we simply combine like terms. We've been doing this since the beginning of algebra. Super, super simple at this point. So we have 2x plus 3, that polynomial, plus 4 minus x, that polynomial. So you can add this vertically if you want. A lot of students like to do that. They'll go, okay, I have 2x plus 3, and you could rearrange this and say I have -x plus 4. And you can kind of add like this because you're adding like terms. So 3 plus 4 is 7. 2x plus -x, or 2x minus x, is x. So your result would be x plus 7. Or, kind of more traditionally, and what I just like to do, you could just rearrange the terms. So I could just put like terms next to each other. So I'd have 2x plus negative x, and then plus 3 plus 4, and then just combine like terms. 2x and negative x are like terms. Again, you keep the variable part the same, so the x stays the same, and I just add the coefficients. So here my coefficient, because I just have a negative there, is negative 1. So 2 plus negative 1, or 2 minus 1 is 1. So I would have 1x, or just x, from combining like terms here. So this would just be x. And then obviously 3 plus 4 is 7. So plus 7. Again, super, super easy. All right, so we have 5n squared minus n cubed. And we're adding to this n cubed minus n squared. So again, just put your like terms next to each other. So I have 5n squared and I have negative n squared. So I'd have 5n squared. You can put minus n squared, or you can put plus negative n squared. Doesn't matter. And then I have minus n cubed, and I have plus n cubed. Okay? So everything's written next to each other. So these are like terms, same variable, same power. And then these are like terms, same variable, same power. So again, I'm just going to say 5n squared minus n squared is what? That's 4n squared. The variable part n squared stays the same, and I'm just subtracting coefficients. So the coefficient here is a 5. The coefficient here is basically a negative 1. 5 minus 1 is 4. So that's how I got that 4 there. And then the variable part, n squared, stays the same. Then we have a negative n cubed plus a positive n cubed. This is basically like saying I have negative 1 plus positive 1. That's 0, right? The variable part would stay the same. 0 times anything, though, is 0, so it would basically cancel itself out. So we'll just have 4n squared as our answer. All right, now we're looking at negative 14x to the 4th power minus 5x cubed minus 5 plus 6x cubed minus 12x to the 4th power minus 1. So I'm just going to start out again by just writing my like terms next to each other. So I have negative 14x to the 4th power. I have minus 12x to the 4th power. I have negative 5x cubed. I have plus 6x cubed. Then I have minus 5 and then minus 1. So these are like terms, these are like terms, and these are like terms. So that's what I can combine. So negative 14x to the 4th power minus 12x to the 4th power. Again, x to the 4th power stays the same. I just add the coefficients. So negative 14 minus 12 is going to be negative 26. So this would be negative 26x to the 4th power. And then if I look at negative 5x cubed plus 6x cubed, x cubed is going to stay the same. I just add the coefficients. So what is negative 5 plus 6? That's 1. So this is going to be plus 1x cubed, or just x cubed. And then lastly, I have negative 5 minus 1. And we know that's going to be negative 6. So then minus 6. And this is already written in standard form. Kind of when I think about doing this process, a lot of times I'll just set it up to where my results are going to be in descending order. Sometimes I forget and don't do that, but if you notice that it's out of order, you can quickly just rearrange it, right? It's easy to tell, okay, this term is of the highest degree, then this is the second highest degree, so on and so forth. So your teacher might not explicitly say it, but for the terms of moving forward, you always want to try and write your polynomials in standard form. And that just means that, okay, I have x to the 4th power here, followed by x to the 3rd power, followed by, x to the power of 0, right? So on and so forth. All right, now I have 11x minus 5x cubed minus 11, plus I have negative 7x cubed plus 3x plus 5. So if I wanted to, I know that this x cubed here is going to have the highest degree. So I could start out with that one if I wanted to, or I could just rearrange it at the end. It doesn't really matter. So I can just say, okay, I have 11x, and then plus 3x, and then I have negative 5x cubed, and then plus negative 7x cubed, or minus 7x cubed, and I have minus 11, and then plus 5. So I put the like terms next to each other. And because I wrote it this way, I'm going to have to rearrange my terms in the end, so I put it in standard form. So if I wanted to save myself a little bit of work, I could have shifted this kind of down here, right? I could have started out with that. Okay, so moving forward, we have 11x plus 3x. 11 plus 3 is 14. X stays the same. So we get 14x. And then we have negative 5x cubed minus 7x cubed. Negative 5 minus 7 is negative 12. And then x cubed stays the same. And then we have negative 11 plus 5. That's going to be negative 6. So minus 6. And this right now is, again, not in standard form because this is x to the first power. This is x cubed. So this one has to go there, right? This has to go in the leading position because it's the term that has the highest degree. So we'd have negative 12x cubed out in front, and then plus 14x in second place, and then minus 6, right? Highest degree, second highest degree, smallest degree. All right, let's look at one that's a little bit harder, and you might not see this in your textbook, but I wanted to throw this in there. You're going to get a lot of these in Algebra 2 where you have multiple variables. You might have 5, 6 variables in there with all kinds of coefficients, and it's not any more difficult. It's just the fact that it's more tedious, and you have to pay close attention to what you're doing. So we have 6x to the fourth power y squared plus 8xy squared minus 2xy plus negative 4x to the fourth power y squared plus 6xy minus x cubed y squared plus negative x to the fourth power y squared minus 6x cubed y squared minus 4xy. So we're going to pay close attention to what the like terms are. So I'm going to start out with, we have 6x to the fourth power y squared. And every time I use something and put it over here, I'm going to go ahead and line it out. Just so I know I've used it, we can go back and erase that later, just to keep track of what's going on. So then plus, I have this term here in the other polynomial. So that's a negative 4x to the fourth power y squared. These are like terms. We have x to the fourth, we have y squared and y squared. So those are going to be next to each other. And then this one will be a like term also. We have minus x to the fourth power y squared. So I've used those three. Now, the next term in the first polynomial, I have 8xy squared. So 8xy squared. Any like terms with that? I don't have an xy squared here. I don't have an xy squared here. No xy squared anywhere else, so moving on. Now I have minus 2xy. So minus, let me kind of write this down here, minus 2xy. So I've used everything from the first polynomial. In the second polynomial, I have plus 6xy. Line that out. In the third polynomial, I have minus 4xy. So I've used all those. Okay. Now everything from the first polynomial is in here. The second polynomial, I still have a minus x cubed y squared. And then I have that in the final polynomial as well. So minus 6x cubed y squared. And so I've represented everything from all three polynomials in this where all the like terms are next to each other. And once you've done that, you can go through and erase your little lines that you put in there if you don't like to see that. Or you can leave it. It doesn't really matter. Okay. So now I'm going to combine like terms. So these three are like terms. So just think about leaving the variable parts the same. Just add the coefficients. So I have 6, negative 4, and negative 1 basically. So 6 plus negative 4, or 6 minus 4 is 2. And then 2 minus 1 is 1. So this would be 1, or just don't have to put anything, x to the fourth power y squared. So I've taken care of these. And then next I have this 8xy squared plus 8xy squared. Nothing to match with that, right? No like terms for that. And then here I have negative 2xy, I have positive 6xy, and I have negative 4xy. So negative 2 plus 6 is 4. 4 minus 4 is 0. So what happened there? Those are going to be eliminated, right? They're going to cancel each other out because 0 times anything is just 0. So these, you could line them out, right? They cancel. Then I'd have negative x cubed y squared minus 6x cubed y squared. These are like terms. So I have basically negative 1 minus 6, which is negative 7. So minus 7 times x cubed y squared. And so this is our answer, but is it in standard form? Let's take a look. The degree for this term is 6. The degree for this term, remember you have a 1 here, is 3. And the degree for this term is 5. So these are not in descending order, right? This needs to get switched with this, right? This needs to go here. So to write this in standard form, I would have x to the fourth power y squared. Then I would have minus 7x cubed y squared. And then I would have plus 8xy squared. And once you get a little bit of practice with this, it becomes very, very easy. All right, so the next thing we're going to talk about is subtracting polynomials. So this is just as easy. There's just one additional step. So to subtract polynomials, change the minus sign to a plus sign and change the sign of each term in the polynomial that is being subtracted away. Very, very simple and goes back to this fundamental rule. If I have 2 minus 3, right, we know that's negative 1. This is the same thing as if I said it is 2 plus, right? Change this to plus and then change this to its opposite. It's the same thing as 2 plus negative 3. It's still negative 1. So that's all we're going to be doing here, using that same rule. So if I have 5p squared minus 4p minus p squared. Again, you know this from earlier. If I see a minus sign out in front of a set of parentheses, in order to remove the parentheses, again, you think about this as just multiplying by like a phantom negative 1. A lot of your teachers are going to say that. You change the sign of each term. So instead of p, that's going to be negative p. This is going to be negative p. And instead of negative p squared, you're going to change the sign. This is going to be plus p squared. So I would have 5p squared minus 4p, and then minus p plus p squared. Okay? So if you're removing parentheses, you change the sign of each term inside the parentheses. That's just the rule, whether you're working with polynomials or anything really. So now I can just set this up just like we did in the previous problems. So I have 5p squared plus p squared, put my like terms next to each other, minus 4p minus p. So these are like terms and these are like terms. So 5p squared plus p squared, that's going to be 6p squared. And then negative 4p minus p, that's minus 5p. So there's your answer, 6p squared minus 5p. Again, whenever we see a negative outside of parentheses, a lot of teachers are just going to say, make this a plus negative 1 and distribute the negative 1. That's going to remind you to change the sign of everything. So this becomes negative 1 times 6x or negative 6x, negative 1 times 5 or minus 5. So that's just a rule to remember just moving forward. Again, not just when you're working with polynomials, but when you're just working in math in general. Negative outside of parentheses, change the sign of each term inside the parentheses to drop the parentheses. All right, so 3x minus 6x plus 5. So again, I'm going to change this to a plus, and then I can think about this as a plus negative 1, right? Each sign inside the parentheses is going to change. So I'm going to have 3x plus negative 1 times 6x is minus 6x, or I could drop the plus sign and just put minus 6x. It doesn't matter. And then negative 1 times 5 is minus 5. 3x minus 6x is negative 3x, and then minus 5. And there's your answer, negative 3x minus 5. What about something like negative 1 plus v cubed plus 12v, and I'm subtracting away 14v plus 7 plus 8v cubed. So again, this part right here, this first part stays the same. So we have negative 1 plus v cubed plus 12v. But again, if you want to save yourself a little bit of time, you can put the polynomial in standard form to start. So I could reorder this, just kind of put the negative 1 behind everything, and now it's in standard form. And then I have this minus here. So what I'm going to do is I'm going to distribute, I'm going to put plus negative 1, and I'm just going to distribute the negative to each term inside the parentheses. So negative 1 times 14v is minus 14v. Negative 1 times 7 is minus 7. Negative 1 times 8v cubed is minus 8v cubed. Okay? So now, again, this first polynomial, I put it in standard form. So I'm just going to follow that format. So I have v cubed minus 8v cubed. I have plus 12v minus 14v. I have minus 1 and then minus 7. And now I just follow this. V cubed minus 8v cubed, that's going to give me negative 7v cubed, right? 1 minus 8 is negative 7. So negative 7v cubed. And then 12v minus 14v, and that kind of looks like a u. Let me kind of make that look a little better. So 12v minus 14v is negative 2v. And then negative 1 minus 7 is negative 8 or minus 8. And notice how this is already in standard form for me. I have v cubed, v to the first power, and you can think of this as v to the power of 0. So it's in standard form. So negative 7v cubed minus 2v minus 8. That's your answer. All right, now we're looking at 4m to the 5th power minus 3m cubed minus 10m. And we're subtracting away 13m to the 4th power plus 4m to the 5th power minus 14m cubed. So again, this first part stays the same. So I have 4m to the 5th power minus 3m cubed minus 10m. And then, look, I have this minus sign that's out in front of the parentheses. So just put plus -1. And I know this is kind of off down to the next line. So let me put the -1 over here, actually. Make it a little easier to see. So the -1, we multiply this by 13m to the 4th power. So minus 13m to the 4th power. And we multiply it by 4m to the 5th power. So minus 4m to the 5th power. Then lastly, we multiply it by negative 14m cubed. So plus 14m cubed. All right, so if I look at this, I can kind of combine like terms here. I don't need to write everything next to each other. That's going to save you a little time. So 4m to the 5th power and negative 4m to the 5th power, those are going to cancel, right? Those are opposites. Next, I'm going to look at this negative 13m to the 4th power. Negative 13m to the 4th power. There's no like terms to combine with this. So we're just going to leave this out in front. That's going to be my term that has the highest degree, so it's going to go first. And I can cross it out as I use it. And then I have negative 3m cubed and 14m cubed. Negative 3 plus 14 is 11. So this is going to be plus 11m cubed. Cross it out as I use it. And then minus 10m. And again, these little tricks that I give you for, crossing stuff out and using that, these are things that a lot of people use just so that they don't get confused. A lot of these problems start getting longer and longer and more tedious, and you need some kind of way to just keep track of what you've worked on and what you haven't, right? So that you get the right answer, because the last thing you want to do is completely understand something and just make some silly error and, not get 100 on your test, right? You want to get the highest grade possible. So we're going to end up with a result here of negative 13m to the 4th power plus 11m cubed minus 10m.